All right. So right now we're going to be doing a review session of data mining 101. It's going to be a high level of data mining and talk about why do we do it, what does it do, and sort of top level, how do we do it? So I already have the KDD here, the process, the knowledge discovery portion of how do you do that. But let's first talk about what is data mining? What is it? What is it? You hear this phrase data mining, and it just seems so elusive. What is it? Well, it's the extraction. It's the extraction of implicit, all right? Meaning we don't know what it is. We have to, it's not explicit. It's not there. It's not for us to know off the bat. So it's implicit, it's unknown, and it's useful patterns. So we're trying to get useful patterns from large data sets. So, we're going to have a lot of data here, and we'll go through a couple examples, and we'll see, how there's this really messy data, right? And we'll get into how we clean it and whatnot, but we deal with it in a cleaning fashion, and we integrate it, and we find feature set and all this stuff, right? But then we're going to find some implicit um, categories, or we're going to find a value. We're going to be able to predict something. So, and also in the broader scheme of it, we're trying to create models that can essentially take new data and be able to predict or classify. If we're talking about cybersecurity, classifying as anomalous behavior, maybe it's spam email, maybe spam or not spam, classification. Or we'll be able to predict like a housing price. We get a data set of the housing prices, and we're able to predict what the housing price will be based off our data set. So, you know, there's a lot to data mining. It combines AI, ML, stats, and database systems, right? And DB systems, right? It's the part, core part of KDD, which is the knowledge discovery databases. Knowledge discovery databases. It's the extraction of implicit. I'm going to bold that. We don't know what it is. We don't know what this data is. We have to do something to to know what it is, to make meaning of it. And so we create models for that. So, and this is all over like, healthcare, green energy, trying to, in agriculture, reduce hunger with agriculture. We can use data mining for that. So there's a lot of, and it's gotten to the point now where everybody wants to do data mining because everybody, that there's so much data out there that with data mining, you can solve some problem. You can predict, you can classify, and that it can be very powerful. And in a capitalistic economy, when the lines of competition are razor thin, the difference between winning and losing is razor thin. Data mining becomes this competitive edge. So how well can you do data mining can sometimes be the predictor of success or failure, or whether you reach your KPIs or whatever you're going to be doing. So um, so we can talk about tasks, right? Let's talk about tasks. Um, predictive, right? There's predictive data mining, right? And then there's descriptive data mining, right? So when we think of predictive, we're thinking of where any new data that we get, we can predict whether it's going to be classified as something, or we can predict a continuous value for it. So classification would be one predictive classification, and how. Like, okay, so what? Classify. So what is using like label prediction, like decision trees, SVM, neural nets, right? These are things that can help with label prediction, which is helping us classify. And then we can go over to regression. Regression, predict a continuous value, like a housing price, like a housing price, right? So that's a predictive task. That's a predictive task that we can do. And then we have descriptive, which I already put down there. So we can go descriptive here. So descriptive, think about a couple different ways that we can do it, right? So when we think about description, we want to be able to describe the data in a better, more accurate way that's useful to you. So, maybe there's clustering. Maybe we can use clustering, which is unsupervised grouping. And we do association rule mining. An example of this would be like market basket analysis, right? Anomaly detection would be another one. And this is for security, from a cybersecurity standpoint, this is our favorite one because we're looking for outliers, we're looking for fraud, intrusion. These are all things that are offensive in nature and, are outlier type behavior that we want to be able to describe. And that also kind of overlaps with the predictive element where we can classify and we can make it, and then based off of that we can make a choice. Maybe it's we have a firewall. A firewall uses rules, but we could have a system that uses data mining um, to predict, maybe or to assess what sort of IDS IPS system is best. And it gathers a bunch of data on different IDS IPS systems that are detecting for outliers, use the mining and be able to say, describe what's the best one. At a more granular level, we can describe what's an intrusion versus what's not an intrusion. And then that's going to be based off of data that's different. And so maybe more granular data. And we can say whether it was an intrusion or not. What is this? Does this count as intrusion? So, there's a lot of interesting stuff that we can do here. Um, and then graph and network analysis. Just bring this down here. Graph and network analysis. That's the next one. Okay. So, oops, sorry, I went tab. We can do now, we can talk about examples. So, and maybe we won't write this, maybe we'll just talk about a classification like credit card detection, churn prediction, whether you're going to lose customers or not. I mean, this is huge in retail and other companies. In a capitalistic society where you're trying to make as much money as possible and you're trying to beat your competitors, churn is a pretty useful data set. Being able to classify that and be able to um, predict churn is huge. So, we can definitely look at that through classification, regression, sales prediction, forecasting. What are our sales going to look like based off of this data? Do some data mining, and then we can do some regression to figure out. And we'll talk about those techniques, right? Clustering, market segmentation, document clustering, biological grouping, right? I mean, this covers a wide array of stuff because data is everywhere. It's all around us, and it's there to be mined. It is there. It's there to be mined, um, as long as it's legal, as long as you have the right permissions for it. Go for it and give people a better product, a better price product, a company that's going to have more money, make more money, and help us forecast weather better. I mean, all of these things are all positive in some way, shape, or form. So anomaly detection for our cybersecurity folks, checking out if an email is fraud. We can use data mining for that. So, there's a lot of different examples, lots and lots of examples of this. So, just the point here is that there's a varied, wide array of applications of data mining. So, um, and that's kind of all I really wanted to discuss here in this clip was that we're going to go on this journey of learning data mining. And I think the next one we'll do is linear models. We'll go over some linear models, but from a data mining perspective, what lens do we look at this stuff through? The beginning with the end in mind. And in the end, what do we want? And we want regression or we want classification. We want descriptive or we want predictive. That's what we're looking for, is having better outcomes for our companies, for our livelihoods, um, for our coworkers, right? For our families. We want better outcomes. And we have now data in databases. There's a bunch of databases are everywhere. That's the foundation of computing, is saving data, memory. So we've gotten to a place in our society, in our world, where we have a bunch of data available. Now it's on the internet or it's in a database, right? Essentially it's in a database, whether it's, available via an API or whatever. I mean, that's, splitting hairs there. But the point is that it's there and it's there for us to find insights from. So that is kind of the main gist of what I wanted to talk about today, and really just kind of get that high level view of data mining and what are we trying to accomplish. So I hope that helps. So see ya. Take care.